How are you, my friends? This is a pre-calculus course, lecture number 38 about ellipses as conic sections. For other lectures, please, you can see the playlist down here, pre-calculus course lectures. Now, the objectives in this lecture will be four things. We will define the ellipse first. We will look at the equations and the graphs of ellipses. We will look at some shifted ellipses. And then we will define eccentricity of an ellipse. What is an ellipse? An ellipse is a set of all points. So it is consisting of points here. You see all these are points connected together in a plane where the sum of the distances from two fixed points, this is focus 1, this is focus 2, or we can call them F, and then the second one is F prime. Both we can call them foci. Foci are always located on the major axis. Or we say simply, foci lie on major axis. Now, again, let's go back to the definition. Point P, like any other point on the ellipse, the distance from P to F plus, why plus? Because we have here sum. The distance from P to F prime is equal constant. And this constant is equal to A. You can see it here down there. Any point on the ellipse you take, any point, even this V or V prime or any point on the ellipse, you take the distance from the point to the first focus plus the distance from the same point to the second focus, the answer will be 2A. All right. So first we say we have a center here in the midpoint of the major axis. See, the major axis is this red one here. So the center is there. Foci are F, F prime. We have vertices are the end point of the major axis. So if we know the major axis, we know one side here is vertex, another we have another vertex. So both we can say vertices. The ellipse has two axes of symmetry, the major axis and the minor axis. And the constant, as we said, is 2A. Now let's here derive the equation. So we start by definition. Remember here, center at the origin. Later, we will see that the center, it will be somewhere else, H and K, shifted. Now we start with the definition here. The distance between P and F plus the distance from P to F prime is equal to A. Write the distance formula, which we know. Square both sides. You can try it yourself, please. And then inside, you will use C squared is equal A squared minus B squared. This rule and this formula can be only used for ellipse. So we have the equation, the final equation for the ellipse, x squared over A squared plus y squared over B squared is equal to 1, where A greater than B. Remember, in ellipse, always, always, always A greater than B. So the bigger number, we call it A. Smaller number, we call it B. So this is major axis horizontal. So we can say this is horizontal ellipse like this. Now, after a few minutes, we will see vertical ellipse. So the vertices here are A0. You see V is A0 minus A0. So you can write vertices plus or minus A comma 0. Endpoint of minor axis, this is 0 plus or minus B. And the red dots are the foci, plus or minus C, comma 0. This is for horizontal. Now let's look at the vertical here. The major axis is vertical. Similar formulas. This is the same formula. C squared is equal A squared minus B squared. Now, why we have B here under the X and A under the Y? Because A squared is always greater than B squared because A greater than B. So if the bigger number under the Y, the ellipse is vertical. If the bigger number under the X, it is horizontal. Now, what are the vertices? Here are the vertices 0A, 0 minus A on the Y-axis. The endpoint of the minor axis will be P0 minus P0, and the foci are 0C, 0 minus C. So if you know one, you can know the other. Now this is the summary. On one slide, this is a horizontal, major axis horizontal, so the bigger number under the X, and then you can imagine the ellipse will be like this, horizontal. If the bigger number here, because always A greater than B in both cases, if you see the bigger number under the Y, then you can imagine the ellipse to be vertical. Always in the ellipse, you can use C squared is equal to A squared minus B squared. Take from here A squared, B squared, then you can find the foci. Let's see example 1. Graph the ellipse and find the coordinates of the two foci. Find also domain and range. Easy, this one. We have to write it in standard form. See, look at the standard form here, either one of these. So by logic, we have to divide both sides by 36 to make it 1. So just say divide each term, or we can say divide both sides by 36. So you have to divide each term by 36. You will get x squared over 9 plus y squared over 4 is equal to 1. Just imagine now that the ellipse will be horizontal like this. Which one is bigger? For sure, 9 is bigger than 4. So the bigger number is a squared. B squared is 4. Now on the next slide, I will find the foci. So what are the vertices here? Minus 3, 0 and 3, 0. This is V and V prime. Now, once we get A squared is 9, B squared is 4, I can use the formula C squared is equal to A squared minus B squared. 9 minus 4, so C will be plus or minus square root of 5. These are the foci here inside. Foci are inside. Now for the domain and range, there's a nice formula you can remember and understand here. If the center is 0, 0 of the ellipse, this is for the ellipse, to find the domain here, see the domain, find x-intercept. But remember to have center 0, 0. If the center is not 0, 0, maybe 2, 3, maybe minus 1, 5 or something, then I will show you in the coming examples what do you do for the domain. So again, if the center is 0, 0, to find the domain, find x-intercept. So now look at the domain here, minus 3 to 3. If center is 0, 0, to find the range, find y-intercept. Y-intercept, you know, let x equal 0, x-intercept, let y equal 0. Then you get the range from minus 2 to 2. That's easy. Let's see another one. Graph y over 4 is equal to square root of 1 minus x squared divided by 25. Give the domain and the range. Now this is a strange equation here. We have a square root. So we have to do something important. Let me show you this something important. To know the shape, the exact shape of the given equation, because we have, remember guys here, we have to graph this one here. To know the shape, square each side. Just to know the shape. Remember here, try to understand this. To know the shape, square both sides. So y squared over 16 is equal to 1 minus x squared over 25. Rearrange it. What do we get here? Complete ellipse. Now, this is here. You see this one? This is complete ellipse. This is the same complete ellipse. But we cannot say the equation we have is a complete ellipse. No. Because the given equation here, look at the last line. The given equation, y is non-negative. So positive or 0. Y is equal positive or 0 here. See, y over 4. 4 is positive, and we don't have a minus here outside. And the square root always a positive number. So this will be half ellipse. The other equation, the equation we get from the squaring is complete ellipse. But y is positive in quadrant. We go to quadrant 1 and quadrant 2. See, remember the ellipse is complete here. But our equation here, this equation, the question in example 2, It is half ellipse. So when we see half ellipse, the domain will be -5 to 5, and the range only from 0 to 4. So this is half ellipse. Now this is the opposite. Given some information about the ellipse, and we have to find the equation. See, example 1 and 2 is the opposite. The equations were given, and then find the other things. Find the equation of the ellipse having center at the origin, so that's 0, 0. Foci 0, 3, 0, minus 3. Measure axis of length 8. After you find it, we graph it. We find the domain and range. The easy part here is the center, 0, 0. We see the foci 0, 3, 0, minus 3. That's on the y-axis. And the length of the major axis is 8. If you remember, the major axis is 2a. Since we have the foci 0, 3, 0, minus 3 here on the y-axis, we can imagine that the ellipse will be vertical major axis. Remember here I said foci lie on major axis. You can remember this always, guys. Simple, nice, easy sentence. Foci lie on major axis for the ellipse. Now to find this is c plus or minus 3. So c squared is 9. Also given the length of the major axis is 8, which is 2a. So from there, I can find a equals 4. Square it, a squared is equal to 16. We have c squared, we have a squared, we can find b squared. Then we can find the equation after that. I know the formula is c squared is equal to a squared minus b squared. So you put the numbers there, b squared will be 7. Since this ellipse is a vertical major axis, so the bigger number should be under the y. So this is x squared over 7 plus y squared over 16 is equal to 1. This is the domain and this is the range. I explained that before. Now let's look at the shifted ellipse. Shifted ellipse means we have an ellipse here, the blue one, center 0, 0, and the equation x squared over a squared plus y squared over b squared is equal to 1. We will shift now the whole ellipse, all these points, we will shift it to somewhere where the center now is hk. So it will be the same form of the equation, but we have, instead of x squared, we have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And remember, a is greater than b always. Now this is the summary for the first part where the major axis is horizontal. So just try to remember the same equation. I put here the equation just to remind you, if the center is 0, 0, this is the equation that we know, so simple. X squared over a squared plus y squared over b squared is equal to 1, a greater than b. The same equation, but we have the center is h and k. So x minus h squared over a squared plus y minus k squared over b squared is equal to 1, a greater than b. Now we put all this information, which is easy. Center is hk. The foci, it was before plus or minus c 0. Then we add h for the x. We add k for the y because the shifting is h and k. Now the vertices, it was before plus or minus a 0. We add h on the x, k on the y. This is the same formula always for every ellipse. C squared is equal to a squared minus b squared. Remember, the vertices are the endpoint of the major axis, and the endpoint of the minor axis is 0 plus h plus or minus b plus k. Now the other type of the ellipse is this vertical. Same idea. I put here also for you to remember, if the center is 0, 0, it is x squared over b squared plus y squared over a squared, the bigger number under the y. Same equation, but we have shifting. So now the center is h and k. So x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And these are the information you need for center, foci, vertices. The same formulas as it was in the center 0, 0, but we add h for the x, we add k for the y. Always remember the length of major axis is 2a, the length of the minor axis is 2b. Now, in these two slides, coming slides, I will show you two methods for finding the domain and the range for shifted ellipse. It's not that easy, but it's up to you which method you use. I will explain both. Method number one, we can say here, use the graph. If we have the graph. Now, before I explain it, method number two says use x-intercept and y-intercept without shifting, then add h for the domain and k for the range. I will explain both. Many people, they prefer method number two. But if you have the graph, method number one is better. Method number one has two cases for sure, because we have ellipse horizontal like this, or the ellipse can be vertical. There's a little change here. So let's go to the first one. If the ellipse is horizontal, and remember, from the algebra we have seen the domain, the values of the x, we know that. Just remember the domain, the values of the x, and the range are the values of the y. So if I need the domain in this ellipse, I can read here. You see that one, domain, use the x values of the vertices. See, the vertices here are 0, 5, this is the vertex, another vertex, minus 25. Suppose we have the graph. So I take the x values, use the x for the domain from the vertices. So minus 20 to 0, that will be the x values. That is the domain here. Now, for the range, use the y value of endpoints of the minor. The minor is b minus 10, 10, and the other b prime is minus 10, 0. So let's take only the y from 0 to 10. I neglect the x. So 0 to 10 is the range. Same thing here if we have the ellipse vertical. Take the domain, the x values. See, this is vertical like this. The x values from the endpoint of the minor, because that's vertical like this. So we take, the domain will be minus 9, the x values to minus 1. And the range will be the y values of the vertices. The y values from minus 6 to 14, closed. That's the range. The domain is the red and the range is the dark green. Method number two may be easier, I'm not sure. Use x-intercept and y-intercept without shifting. Remember, not enough. Then add h for the domain, the x values, add k for the range, which is the y values. Look at this example here. This is a complete ellipse shifted, not easy. Directly find the center. Minus 3 in the x and then 5 in the k, so it will be h of k. Just leave it now. Now let's go to the domain. Suppose there is no shifting, suppose. Without shifting the x-intercept, we let y equal 0. Without shifting means, guys, you have to think this is x only squared and this is only y squared. Then we will use h and k later. So without shifting, to find the domain, find x-intercept. Let y is equal to 0. So x will be plus or minus 7. So I write here minus 7 to 7. But I have to add the h because there is a shifting. And h we know is minus 3. So minus 10 to 4 is the domain. Now let's see the range. Without shifting, y-intercept, let x equal 0. So y will be plus or minus 4. I put here minus 4 to 4, then I will add plus k plus k. And k I know is 5, so the final range will be 1 to 9. If you like it, you can use it. Let's see example number 4. Good example, which is not difficult, medium question. X minus 2 squared over 9 plus y plus 1 squared over 16 is equal to 1. This is ready. We don't have to do anything there. Then find the vertices, the foci, the domain, and range. First, you can see that the center is easy to find, which is h and k. So x minus 2, that h is 2, and the k is minus 1. Now, the bigger number, where's the bigger number? The bigger number, 16, yes. 16 is a squared, so a plus or minus 4. So the smaller number, b squared, is 9, so b plus or minus 3. We know that it's vertical because the bigger number under the y. So the vertices, we can write the formula. Remember the vertices here without shifting, it will be 0a, 0 minus a. So what do? 0 plus h, a plus k. 0 plus h minus a plus k. We know h and k, and we know the a plus or minus 4. When you simplify, the vertices becomes 2, 3, 2 minus 5. Now we have a squared, we have b squared, we can find c squared by the formula of the ellipse. Now from the previous slide, we have seen the vertices 2, 3, and then 2 minus 5. These are the vertices. We will find now b and b prime. So let's see, the foci c squared is equal a squared minus b squared. So c will be plus or minus square root of 7. Look at the formula in the foci, 0 plus h plus or minus c plus k. Just put the numbers there. This is f and f prime. Let's see the endpoints of the minor x's, which is b, b prime. We have the formula plus or minus b plus h, 0 plus k. So I put the numbers here. I have the b. See, b squared is 9, b plus or minus 3. I have the h is 2, and k is minus 1. So I will get b here, 5 and minus 1. I will get b prime, minus 1, minus 1. Now if I use method number 1, the domain becomes minus 1 to 5, and the range will be minus 5 to 3. Example 5 is not easy, but important. Find an equation of the ellipse whose foci are minus 3, minus 3, 7, minus 3, and passing through the point 2, minus 7. So what information do we have on this ellipse? We have the foci, minus 3, minus 3, it's there, 7, minus 3. So the foci lie on the major axis. These two on the horizontal here. So the major axis is horizontal, so the whole ellipse is horizontal. So we have f prime, and there is a point here on the ellipse, P, 2 minus 7. I will call it point P, 2 minus 7 on the ellipse. Now we will see now. The distance between f and f prime will be 2c, we know that. So the absolute value of, remember, absolute value of a minus b will be the distance. So 7 minus minus 3 is equal to c. C will be 5, c squared will be 25. Leave it. Now the center here, in the middle here, center is the midpoint of the line segment f prime f. So I just find the center from the midpoint. So it will be c2 minus 3. Now the only way I can find a or b is using the point on the ellipse and use the definition. If you remember, the distance from P to F, we have P, we have F, plus, remember, plus sum. The distance from P to F prime is equal to A. Then from there, we can proceed with many numbers, but not difficult. Square root of 7 minus 2 squared, plus minus 3 plus 7 squared, etc. Use the distance formula that you know, and then suddenly we will get square root of 41, the first one, plus square root of 41, the second one, is equal to a. I can add these two radicals. So divide by 2. So a will be square root of 41, a squared will be 41 only. Now you see squared is equal a squared minus b squared, then we get b squared 41 minus 25, 16. Now, since the major axis is horizontal, so we have the bigger number a squared 41 is under the x minus 2 squared, and 16 is under the y plus 3 squared. That's the equation of the ellipse. To find the domain and range, let's use method number 2 on the next slide. So we have the equation written there. Method 2 says, without shifting, let's find x-intercept. So we assume here x squared and here y squared. But we know the center is 2 minus 3. This is h and k. We will use them. So without shifting, let's find x-intercept. Let y 0. So x will be plus or minus square root of 41. So the domain will be minus square root of 41 plus h, 2 square root of 41 plus h. That will be the domain. Now the range, without shifting, find y-intercept. Let x equal 0. So y will be plus or minus 4. So from minus 4 to 4, then we add k. So it will be minus 7 to 1 is the range. Question number 6, write the equation in standard form. See, this is not in standard. Y squared over 4 plus x squared plus 6x minus 3y is equal to 2. And then after that, you can find anything related to this ellipse. So let's rearrange it and make it standard. So we have to think of the idea completing the square, remember. So first we multiply by 4 the whole equation on both sides. 4 is cancelled here. 4, you see 4x squared, I put it here, and then I put the y minus 12y with the y, and then 6x, it will be 24x equals to 8. Make sure you multiply every term by 4. Complete the square now on the x and y. So y squared, the coefficient here is 1, so that's fine, leave it. Now here the coefficient of x squared is 4, so I have to take 4 as a common factor only from the terms that they have x. So 12 divided by 2, 6 or minus 6, square it, becomes plus 36 minus 36, we add and subtract. Inside here, 6 divided by 2, 3, you square it, you add 9, subtract 9. Now, the first 3 terms here becomes perfect, y minus 6 squared, and this one here, 4. Inside, we have x plus 3 squared, and then 4 times minus 9 is minus 36. And here we have minus 36. On the other side, minus 72 plus 8 is 80. Let's divide by 80 both sides. So y minus 6 squared divided by 80 plus x plus 3 squared divided by 20 is equal to 1. This is the ellipse. Now you can find a squared is 80, b squared is 20, etc. You can find anything you like. Now let's move to the nice idea property about ellipse. We call it eccentricity. Eccentricity is a number between 0 and 1. Eccentricity, it measures the roundness of the ellipse. So if the eccentricity is 0, the ellipse is almost a circle. If eccentricity is approximately 1 or close to 1, the ellipse is long and thin. But it will be always between 0 and 1. The eccentricity formula is E equals C over A. It's a positive number between 0 and 1. C is the distance from the center to the focus, and A is the distance from the center to the vertex. So the eccentricity is a measure of how stretched the ellipse is. Let's see a nice example here. Write an equation for the ellipse with eccentricity 3 over 4 and foci 0 minus 2, 0, 2. Try to think and then look at the solution. Now the center here is 0, 0 for sure because it's the midpoint of the foci. The eccentricity E 3 over 4 is given. So from the given we can say C plus or minus 2. When you square it, you get C squared is 4. Now the eccentricity formula is E equals C over A. 3 over 4 is equal to C over A. Now we cross multiply. 3A is equal to 8. So A is 8 over 3. When you square it, you get 64 over 9 is A squared. We have C squared, we have A squared. We can find now B squared. Use the equation on the next slide. So we know for the ellipse, we can say C squared is equal to A squared minus B squared. C squared is 4. A squared is 64 over 9. See, from there we get 64 over 9 minus B squared. So take B squared on the other side here. Take B squared on the other side. Bring the 4. Make the LCD 9. So B squared will be 28 over 9. Now be careful here, please. The ellipse is a vertical axis. So B squared will be under the X and the bigger number 64 over 9 under the Y. Now example 8 says find the eccentricity of the ellipse whose equation is given by x squared plus 4y squared plus 20x minus 40y plus 100 is equal to 0. Now from the equation, it's very clear that we have to complete the square as we did many times. Complete the square on the x, complete the square on the y. I will do it here in details so you can learn better. So I put all the x's together, x squared plus 20x. I'll take the y's here, and then there is a common factor, 4, and only the y's, plus 100 is equal to 0, because I need the coefficient of x squared and the coefficient of y squared should be 1. Now inside here, 20x, divide by 2, the coefficient of the x, divide by 2, 10, square it, plus 100 minus 100. We go to the y now, minus 10 divide by 2 minus 5. Square it, you add 25, subtract 25. And then we leave this plus 100 is equal to 0. This one x plus 10, this one here. The first 3 terms will be perfect, minus 100. 4, this is y minus 5 squared minus 25 plus 100 is equal to 0. This one, we can just take the big bracket, minus. Here we have a 4, so we multiply by the first one and by the second one. So it will be minus 100 plus 100, and there is a minus 100. Now we can write it in standard form. So it will be x plus 10 squared plus 4y minus 5 squared is equal to 100. Let's divide by 100. So divide the first term by 100, by 100, by 100. This becomes x plus 10 squared over 100 plus y minus 5 squared over 25. We cancel here by 4 is equal to 1. So the bigger number here under the x is a squared and b squared is 25. So we can use the formula c squared is equal to a squared minus b squared. So c squared will be 75. Now c plus or minus square root of 75, which is plus or minus 5 square root of 3. To find the eccentricity, take the positive numbers. E equals c over a. C is 5 square root of 3, and a is 10. Divide by 5, so the eccentricity will be square root of 3 over 2. Now that's the answer for the question number 8. Now more information about the ellipse, I put it as a gift for you on this slide. You see here? For example 8, I put the graph. You can see it, very nice graph. The center is there, the vertices, the foci, the domain, and the range. Now, in this lecture, this is lecture 38 of the pre-calculus course, you can find 2 parts for practicing questions on this topic. Part 1, there are 6 questions. Part 2 also, there are 6 old exams questions. So this is part 1 about ellipses. Question number 1, find the eccentricity. You can do that. There is a similar example. Question number 2, find all these. Question number 3, the ellipse. It has Foci minus 1, 2, 3, 2, passing through the point 3, 5. Find the equation, find the length of the major axis. You can try these, please. What does the equation represent? Try to see. And then find an equation of the ellipse. We have the vertices, V1, V2. We have the foci also, F1, F2. Now, number 6, find the value of E if the graph of this equation is an ellipse. Try to think what is the value for E. Now here you find the answers for number 1, 2, 3, 4, 5, 6. For complete solutions of these 6 questions, part 1, you can see the video on ellipses, conic sections, 6 solved questions. Now part 2 will be 6 old exams questions about also ellipses. We have question number 1, graph the ellipse, find the coordinates of the foci. Find the eccentricity of the ellipse given the foci passing through the point 3 and 1. Find the equation of the ellipse with this information on the minor axis passing through the point square root of 5 to square root of 10. Find an equation of the ellipse foci 4, 3 minus 4, 3 and y-intercepts 0 and 6. This is really nice. Question number 4. Given the equation y equals minus square root of 4 minus 9x squared divided by 2. If the domain is AB and the range is CD for this equation, then find the value of A plus C times the B. So don't use the D. Be careful here. Domain is AB and the range is CD. Find the value A plus C times B. Find the eccentricity of the ellipse whose equation is this. Find also vertices for side domain and range. Now, as usual, these are the answers for the 6 questions. For complete solution, please, you can see the video on ellipses, conic sections, lecture number 38, pre-calculus old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture number 38, and we are reaching the end, which is number 40 is the last lecture in this course. I wish I can see you in another video with another topic. Thank you for listening, guys.